Hello and welcome to this video about adding and subtracting rational expressions. This video is a part 2, and it goes with another video I made about adding and subtracting rational expressions. The learning target of part 2 is to add and subtract rational expressions with different denominators. And we're going to start off with what I'm going to call sneaky denominators. And there's a better phrase for this, and the sneaky denominator could be thought of, or the better phrase is an inverse denominator. Denominator. All right. And so it's a denominator that's really similar to, or two denominators that are really similar to each other, except with one little detail. And so let's take a look at an example. Let's say we had something like t squared over t minus 3 plus 3 over 3 minus t. Now what I'd like to highlight is that we have in the denominators the same players. We have 3's and t's. We have the same sign as well. The difference is the order. The 3 and the t are reversed in their order. And so that is what we call an inverse denominator. Now what we can do with this is take out a -1 from one of these. And so that's what we're going to do, is we're going to take out or factor a -1. So what I'm going to do, I'm going to rewrite this. We have t squared, t minus 3 plus, and then the way I'm going to write this, make it 3 over -1, which becomes negative times -3 plus t. Now, I can use the commutative property to move those guys around. And when I do that, I'll get t minus 3. I could also use properties of fractions to move this guy up there. And so what I'm going to end up getting is t squared over t minus 3 plus -3 over t minus 3. Now I have a common denominator, and I can combine these to get t squared minus 3 over t minus 3. And that's as far as I can take that one. Okay, now, you've got to watch out for those negative signs. Let's try another example. So, switch colors. Let's go with 2p over p minus 1 minus 2p 1 minus p. So again, notice the similarities between the two denominators. Same things, p and 1. Different order. So what we're going to do, rewrite the first one as is. Then we'll take out a -1 in the denominator of the second one. So -1, and then what I'm going to do, I guess I'll take my time here. -1 plus p is all over 2p. Now I'm going to bump this guy up here, and I'm going to reorder that. So that way we have 2p over p minus 1 minus -2p over p minus 1. Now we have common denominators, and we can combine them. But we got to watch out for our negative signs. We have a negative and a negative, so that's going to become a plus. So 2p plus 2p is 4p over p minus 1. Check to see if anything can be factored, and it can't. So we box it and we walk away. So that's how we deal with these sneaky denominators, inverse denominators, where again you have the same components, including the sign, but the order has been flipped. You factor out a -1, and then you bring that -1 to the numerator, and then you'll have that common denominator. So at this point, I'm going to do some other examples. And if you feel confident with this, you can stop watching now and you can try your homework. If not, you can continue to watch, where we'll just look at more examples of having uncommon denominators, having to find those common denominators to simplify. So in this example, let's say I have 5 over 2x plus 2 minus x over x plus 5. Okay, so here I'm going to have to do some work, and I'm going to have to identify what is my common denominator. I like to do that off to the side, where I write CD, common denominator, and I think about what that could be. Now, I notice that I could take a 2 out of here, but that doesn't do me any real good. Sometimes, books, tests, whatever it might be, might try to sneak some numbers in there to kind of throw things off, but that's not the case here. So I'm just going to have to multiply these two together. So my common denominator is 2x plus 2 times x plus 5. And so I have to multiply this guy by x plus 5, x plus 5, and then this one by 2x plus 2, 2x plus 2. So let's see, plus 5, plus 5. All right, so that's going to give me 5x plus 25, and this is all over our x plus 5, 2x plus 2, minus 2x squared plus 2x, all over the same denominator, x plus 5, 2x plus 2. We have that common denominator, so we can combine, but we have to be careful. This is in parentheses, and so I have to distribute my negative sign to both of these. So when I do that, and I'll do that in a different color, this becomes a plus negative 2x squared minus 2x. And so I'll have negative 2x squared, and then 5x minus 2x for plus 3x, plus 25. And then that's going to be over x plus 5, 2x plus 2. At this point, we check to see if the numerator can be factored, and I don't think it can be, at least in a way that wouldn't help us. 25 does not have a multiple of 2 in it, so that wouldn't help us out at all. And then I did a little bit of exploring on my own to see if I could take out x plus 5, but that didn't seem to work out either, so this is as far as we can go. And then one final example. This one, we have n over 2n plus 10 plus 1 over n squared minus 25. Now here it's going to help us to factor because we're going to see some similarities. So okay, I'll rewrite. Actually, no, I won't rewrite. We'll just factor in a different color here. I'm going to take out the 2. Now I have n plus 5. Down here, this is a difference of squares, so I have n plus 5, n minus 5. So my common denominator is all of these, but the n plus 5 overlaps. So I only need one of those. So the common denominator is going to be 2, n plus 5, n minus 5. So the only thing I'm lacking here in this fraction is the 2. So I'll have to multiply this one by 2 over 2. Here, the only thing I'm lacking is the n minus 5, and so I'll multiply this one by n minus 5, n minus 5. Keep in mind down there, you're foiling it out. But we actually don't even need to FOIL it out. So when I multiply, I'll get n squared minus 5n, and that's all over 2 n plus 5, n minus 5, plus 2 over 2 times n plus 5, n minus 5. Combine my like terms. There's a 2 there, so this is easy enough. We'll get n squared minus 5n plus 2 all over 2 times n plus 5, n minus 5. And again, in our numerator, it does not look like there's anything useful to factor out. And in fact, I can't think of factors of 2 that would get 5 anyways. So that's as far as we can take that. We box it and we walk away. So hopefully you found these examples to be helpful. Again, I want to stress, there are the sneaky denominators, those inverse denominators. But then other times it's just about finding that common denominator, taking your time, distribute, watch negative signs, combine like terms. And after you do a couple of these, it becomes a little bit easier. So good luck with this, and let me know if you have any questions.